So in today's video, we'll be creating a lot of the infrastructure that we need for our web app. Specifically, we need to create a Lambda that gets invoked whenever a user uploads an image onto our S3 bucket. And we'll be triggering this through an event notification. So this is my infrastructure as code package. And what I'm going to do is walk through all the resources that I create through code and then go into the AWS console and show you how the code that we write is correlated to all the infrastructure that gets created in AWS. So then the first thing I want to do is create the S3 bucket to store the processed images. So that's going to be this RGB splitting process bucket right here. So here in this line of code, I'm creating an S3 bucket named RGB splitting process stack. So stack refers to whether I'm in a development environment or I'm in a production environment. So now if I go into the AWS console and then go into S3, you'll see that I have a bucket here named RGB splitting process dev. So this bucket right here corresponds with this line of code here. And then here with the bucket lifecycle configuration, what I'm doing is I am taking this bucket that I made and I'm giving it a lifecycle configuration. So essentially, whenever you upload an image or a file onto this S3 bucket, we have a lifecycle rule that states that this object will be expired after 1 day. And this is intentional with our web app because we're not doing SSO and keeping a history of all the uploads that you do. You upload an image, wait for it to be processed, and then you get it back. Once you refresh the page or you leave the page, you're not going to get the previous uploads that you did. So this just makes it so then that I don't have to store a lot of stale images and files in my S3 bucket. So here, if I go into the AWS console and then I go into management and then go into lifecycle rules, you'll see that I have a lifecycle rule named delete after 1 day. And then if I click on it, you'll see that after 1 day, the objects expire and gets deleted. And then here we're creating course configurations and policies for our S3 bucket. So what course configurations and policies does is it essentially whitelist specific domains and origins that you want to have access to your S3 bucket. So here with this course configuration, we're getting the bucket ID and then we're adding this course rules. So we're allowing all headers. We're also allowing these specific methods to our S3 bucket. On get request, post request, put, delete, and head. And then here, we're accepting allowed origins. This is this line of here. So if I'm in my development stack, in my development environment, I want to accept requests from localhost 3000. This is because when you run npm run dev and you want to spin up a local instance of your web app, it's going to be running on HTTP localhost 3000. So if you want to upload an image from your development environment, you need to allow requests from localhost. Also, if I'm in my production environment, I want to allow requests from vercel.app. So with this course configuration, when you go into S3 and you go into permissions and you scroll down to course origin, you see course right here, your course configuration. And you see that you have your allowed headers, your allowed methods, origins, and all this stuff here. So now that we created the S3 bucket for our web app, we now need to go ahead and create the Lambda that gets invoked whenever a user uploads an image to our S3 bucket. So before we can even create this Lambda, what we first need to do is to create an IAM role that we can give to our Lambda that has the necessary policies and permissions to access different AWS resources. So here in this line, we are creating an RGB splitting Lambda IAM role. So essentially what this is doing is anyone that has access to assume this IAM role, you're also letting AWS Lambda assume different roles to make requests and access your AWS resources. So now if you go into AWS, we go to our Lambda, and then we go into configurations and permissions, you'll see that we have an IAM role, RGB splitting Lambda role. And then here, if you go into trust relationship, you'll see that we have a trusted entity with this STS assume role for Lambda AWS. So the next thing that we're doing is we're creating an IAM policy to allow our Lambda to have access to our S3 buckets. We want to state in this policy that we want to allow S3 get object actions on our RGB splitting user upload bucket. And then we also want to allow put object requests onto an RGB splitting process bucket right here. So then we take this IAM policy and then we attach it to our Lambda's role. So then if you go back into the AWS console, then you go into RGB splitting Lambda IAM role, and you look at your permissions here, you'll see that we have S3 get object actions on our RGB splitting user upload bucket. And we also have put permissions on the RGB splitting process bucket right here. So with that, our Lambda has access to get objects from the user upload bucket and then access to put objects in the process bucket. And here we're also attaching another IAM policy named AWS Lambda Basic Execution Role. It allows our Lambda the ability to output logs. So whenever we need to debug and root cause different issues and stuff like that, our Lambda can output logs for us that we can view in CloudWatch. So now that we have the Lambda IAM role and attach all the policies that we need to it, we can go ahead and finally create the Lambda function for ourselves. Here, I'm creating a Lambda function named RGB splitting Lambda. And then here, I'm passing in the code for all the Lambda code. And I'm also passing in the Lambda IAM role as well. So here in the handler property, this just tells Lambda where is the entry point for my Lambda. So I go into Lambda code here, you'll see that I have a method named Lambda handler. So this is going to be that entry point. And then here I pass in the Python runtime. And then in the environment part, you can pass in all the environment variables that your Lambda should have. So whether I'm in my development stack or I'm in production stack, I'm going to pass in the bucket name accordingly. So then here in my Lambda logic, whenever I want to access that destination bucket, I'll do os.environment and then the destination bucket, right? So then if I go into Lambda in the AWS console, I'll see that I have a function named RGB splitting Lambda. And then if I go into the code here, this is the code that's going to run whenever my Lambda gets invoked. I also pass in the Python 3.11 runtime, that handler reference, and all the other configurations that I added to this Lambda. So whenever a user uploads an image onto S3, we want to invoke a Lambda on that specific uploaded image. And we can do all that through an S3 event notification and trigger. So here we create a bucket notification for this RGB splitting user upload bucket. And then we want to invoke this Lambda here, our RGB splitting Lambda, for whenever an S3 object gets created in this S3 bucket. So then if I go into the AWS console and then I go into my Lambda here, you'll see that I have an S3 trigger right here. You'll see that I am listening on this RGB splitting user upload bucket. And I'm also listening for a specific event, the object created event. So whenever this event happens, I want to trigger this Lambda here. So now that we created all the infrastructure for our web app, let's go ahead and dive deeper into the Lambda code specifically. So when I created the Lambda, I'm passing it a reference to my zipped Lambda code. So if I look into my sidebar here, you'll see that I have a file here named lambda.py. And I also have a zipped version of that code here. So in this Lambda code here, you'll see that I have a method named Lambda handler. So this is going to be the entry point for whenever our Lambda gets invoked and runs. So here I log the S3 event and I iterate through every record in that event. I am extracting the S3 object from the record and I'm getting the bucket name and the object key. And here above, you see that I've initialized an S3 client using the Boto3 library. I'm using the S3 client to get an S3 object with that bucket name and the object key. So user uploads an image to S3, it invokes a Lambda, and then this Lambda will grab the image from S3. So here, file data is getting that S3 object and grabbing all the contents of it. So in our case, it's going to be the image that the user uploaded. And in a future video, I'm going to be performing RGB splitting on it. So whenever we do RGB splitting on an image, we're going to be uploading 3 images to our process bucket. I'm using the S3 client to put an object into S3. And I'm taking the destination bucket from the environment variable here, and I'm giving it a key of color and object key. So I'm taking the original object key and I'm prepending the red, green, or blue prefix. And I also give it the body of file data. And then I just log that every time. So with all this implemented and deployed, I'm going to walk through this entire process and then show you all the logs and the AWS resources that gets triggered whenever a user uploads an image to our web app. So here I have a local instance of my web app up and running, and now I'm going to upload a file named youtubedemo2.png. So now if I go into my AWS account and I go into S3 and then I go into my user upload bucket, you'll see that I have an object here named youtubedemo2.png. So then referring back to the diagram, here I upload an image, and then I made an API call to generate the pre-signed URL. And then the browser uploaded the image from the browser onto S3. So then now if I go to my Lambda, you can see a few things here. Here, if I go into my CloudWatch metrics, you'll see that I have invoked this Lambda twice in the recent 3 hours here. And then I can also go into my CloudWatch logs and then click on this log stream here. And then you'll see here that I logged the S3 event here. And then you'll see here that every time I upload an image onto the S3 in the process bucket, I am logging this here, uploaded object key to destination bucket. So then now if you scroll down, you see that I logged that event 3 different times here, right? I uploaded the red version, the green version, and the blue version as well. So now if I go back into my S3 buckets and I go into the process S3 bucket, if I go into the blue directory, you see that I have an S3 object named blue/youtubedemo2, and then likewise for the green, and then likewise for the red as well. And then with that, we walked through and demoed all the infrastructure that we created for our web app. We created a new S3 bucket to store all the process images. We created a Lambda that gets invoked whenever an object gets uploaded to our user upload bucket by creating an event notification. In our Lambda code, we grabbed the user uploaded object from the user upload bucket, perform RGB splitting on it in a later video, and then we upload the results back into a process bucket here. So with all that, I hope you learned something new, and I'll see you in the next one.